Hi, everyone. Last speaker. I'm a biomedical engineer by training, just like David Kirchhoff. Very proud of my profession in terms of the accomplishments that we've had over the last 50 years in diagnostics, therapeutics, surgery, rehab, the design of facilities, innovations at the molecular level. Lots of accomplishments over the 50 years. And you know what? We're also a really hot profession, too. Look at that. Number 2. Biomedical engineer. You know, for years I've been trying to explain to people what it is that I do, and now I'm in a top 5 list. And like software engineer, I used to be a software engineer. You know, I showed this list to Joe Cafazzo, and he actually thought it was some kind of joke. Not because biomedical engineer was number 2. He says, how did actuary become number 1? Right? No offense to actuaries. And you know, it's in pop culture now as well. Has anyone seen this movie? Gravity? It's the hot movie right now, number 1 movie in the country. The main character is a biomedical engineer. That's another first, another first. But I have a confession to make. You know, with all the good work that we've done, we have done a lot of harm as a profession. And I think you know what I'm talking about. For every innovation, there is a very poor product out there. And my team back in Toronto, a group of human factors professionals, have compiled a sample of some of the technologies that come through the doors of Toronto General Hospital. And I want to share it with you right now.
These letters and stuff are too small. Yeah. Wow. If this took me this long in real life, I'd be in trouble. I'm just saying, I could have done 2 paragraphs by now, but I'm struggling.
I'm so confused. It's way too confusing. It's killing me.
I don't know what's going on.
Oh, schnocks. Why isn't this opening?
Unbelievable. 50 items there and I've got to choose your own volume and I don't know where it is. I have no idea.
I find this is not user friendly at all.
I just wish I could edit here. I don't understand why this is so complicated.
Where's enter here? Where's enter on it?
Again, on behalf of the profession, I apologize. You know, it's painful to watch that on many levels. Can you imagine being connected to one of those infusion pumps where the nurse is trying to program it in a safe manner? It's very serious, and I think it's largely we've lost something in the design of health technologies. Is we've lost empathy, or perhaps we never had it. In order to move into the realm of personalized medicine, bringing these technologies into the home, we've got to get serious about it because we have these 6 chronic conditions that consume more than 70% of all our spending. And if we're not going to be able to achieve that unless we have technologies that are better designed and more effective. And I'm really an advocate of patient self-care. Our center was created more than a decade. Is not simply patients as partners, but patients can do a lot independent of the health system. And you know, in order to get that far, we have to really consider this empathy in design. This is our design process. You'll see that it's not atypical, but what it has in it is a lot of iteration. You can see the concept of build and evaluate and evidence. And when we talk about evaluation from a human factors perspective, we talk about usability, but we also want to create applications that in the end have value. And that requires rigorous evaluation in the form of RCTs. Do you remember your first computer interface? Huge, steep learning curve on something like this. You know, we've gotten better at user interfaces, and this was a consumer user interface in the early 1980s, believe it or not. But we still have a lot of work to do if we're going to really engage the consumer. Remember this device? You probably owned one of these devices. You probably didn't own a second one. Do you remember why you didn't buy the second? It was because of that graffiti. Remember you had to relearn how to write? What kind of input method is that? So that was too much for most people. You know, human factors has huge implications even in other industries. This is Chernobyl 1986, originally attributed to human error The operators made an error that caused this explosion back in 1986. But in fact, it was physically impossible for those operators to realize. They'd have to have been in 3 different parts of the plant looking at 3 different panels to make a determination that the core was going to overheat. Same thing with 3 Mile Island. Right? An indicator on a panel that misled the operator to turn off the cooling systems. Again, it misled them to making an error. Even in the US military, this device, do you know what this device is? It's called a plugger. This happened in 2002 in the midst of battle. This device was used to basically calculate the position of the enemy, the Taliban, across the mountain range. You point at your enemy with the rangefinder. It calculates this delta, this GPS position, and you can call in a bomb strike, and that's what they were about to do when the batteries went dead. Now, okay, calm down. You just changed the batteries. What they didn't know, or perhaps what they forgot from all their training that they do, is that this device defaults to your current location when you change the batteries. So they called a bomb strike in on themselves, killing 3 soldiers, injuring 17 others. And this was the reaction from the Air Force. We have a serious training problem that needs to be corrected. We need to know how our equipment works. When the battery is changed, it defaults to its own location. We've got to make sure our people understand this. The entire burden placed on the individual. Now I ask you, as the engineer who designed this product, where was the empathy? Why would you create a device that calls in bomb strikes? Why would it ever display your current location? Perhaps that engineer needed to be embedded within that environment to fully understand, appreciate what a US soldier goes through in using this device. It has implications everywhere, and design has implications everywhere. Do people recognize this ballot? Some of you may even have filled out this ballot back in 2000. Do you remember this election? Came down to Florida. This is the infamous butterfly ballot of 2000. And Al Gore and George W. Bush. Now, if you wanted to vote for Al Gore, which hole would you punch? Well, he's the second one listed, right? So you're going to punch the second hole, right? No. Punching the second hole will give a vote to Pat Buchanan, and Pat Buchanan got a disproportionate number of votes in this election. There were also 17,000 ballots that had both the second and third hole punched. What was going on there? Well, they realized their mistake. They punched the second hole, and then they punched the third hole. What happens to a ballot that has both the second and third hole punch? It's spoiled ballot. It's not counted. No, of course, in order to vote for the second person listed, you punch the third hole that's labeled 5, right? Of course. So 17,000 spoiled ballots. Do you realize that Al Gore only lost the election by 537 votes? Now I ask you, design matters? Of course it matters. What would have happened if Al Gore had become the 43rd president of the United States instead of George W. Bush? You don't need to answer that. I can ask that question because I'm Canadian, right? So back to this notion of empathy and design, and if we're going to make this transition to patient self-care, I was exposed to these patients on in-center hemodialysis more than a decade ago, and my colleague, Chris Chan, a nephrologist, wanted to do something that at the time was considered very radical. You know, going to the hospital for end-stage renal disease and get renal replacement therapy in this form, it's every other day, 4 hours of treatment, travel back and forth. It's not a great existence. He was suggesting that we move it into the home. We bring that dialysis machine and put it in the home. We fix the plumbing up, and we train these patients how to use the machine in 6 weeks. You know, a lot of people thought he was crazy. It even sounded reckless. Plus the fact that, you know, these patients have to learn how to self-cannulate. Can you imagine? Self-cannulating yourself, not 1 needle, 2 needles on a daily basis, on a nightly basis. The hope here is that they do this nocturnally. The hope that with the opportunity to be able to dialyze more frequently, they'll have better health outcomes. And you know what? There was a whole slew of very young women who signed up to this. Yvonne Maffei, Marie Saginaw, Bella Agarwal. Why? Because they wanted to have a family. Highly motivated. As an end-stage renal disease patient, they had very little chance of getting pregnant, let alone bringing it to full term. But you know, they did it, and they took this huge personal sacrifice in order to perform a really radical therapy in the home. And now there are dozens of children born to women at Toronto General who have done this over the last decade, all born to women that normally would not have been able to achieve this, just because these patients were given the opportunity to perform a radical form of self-care. And he went on, Chris Chan, to show many other health benefits of home hemodialysis, including greater patient autonomy. These patients are going back to school, going back to work, and it's actually cheaper than doing it inside the hospital, of course. The work that I did with him is that we were trying to lower the barriers for everyone, including the other family members, how to deal with self-cannulation. And this last one, self-efficacy, and this hit me kind of personally because my father had end-stage renal disease, and looking at these machines, again, personally embarrassed at how complex they were, unnecessarily complex. And I asked my father, would you consider it? And he said, there's just not a chance, Joe. There's no way I can operate that machine. And I really couldn't blame him, because even the knob on this device, this is a simple knob that just adjusts the blood flow within the machine. Of course, it's labeled potentiometer, right? And if you're an electrical engineer, you know what a potentiometer is. This is what the textbook definition of potentiometer is. Not very helpful, is it? So again, unnecessary complexity. These women did this despite the barriers that we put in front of them. Imagine what would happen if we could create technologies and systems that allowed them to perform self-care. And then there was this other fellow, I don't know if you heard about Hu Song-wen in rural China. He actually built his own dialysis machine. He had no choice. His life savings were depleted for the last 13 years. He has been mixing his own dialysate. He has his own small pump, and he gets his 82-year-old mother to help him. And he's been doing this for the last 13 years. These people are, in some respects, exceptional, but I don't think that they're unique, given the challenges they have with their personal health, and given certain opportunities, they can do amazing things. So I ask now, if these patients, given certain circumstances, can do this extreme form of self-care, what else is possible? So I was tasked with my colleagues at the Hospital for Sick Children across the street from Toronto General. What could we do for kids, particularly adolescents, teens with type 1 diabetes? This is a difficult group, and they explained to me that they don't always do what they're told. They don't eat properly. They're not listening to their parents, and they're going on and telling me this, and they didn't really need to tell me this. I have a teenager, and this is another Cafazzo. This is Aiden Cafazzo. And look how happy he is to be with his dad in Piccadilly Circus during the Olympics last summer. And Aiden doesn't have a chronic illness, thankfully, other than being surly, right? So he, I can't imagine what it's like. Well, in some respects, I'm going through this indirectly with my niece who was diagnosed about 4 years ago. And, she's doing great, but her mother says now that she's approaching adolescence, the burden of care is getting to her. And she just doesn't want to do it anymore. And, we don't do these kids much favors in terms of what we're asking them, and the constant number of finger pricks and the tools that we give them that seem like they're out of the 1970s. Very medical, very cold devices. And, we turn to the mobile health solutions, and this is the idea that we had with the Hospital for Sick Children to create this app called BANT. And we wanted to leverage things like social media because we knew that this was popular in some sense, but also that there was this thriving community of people with diabetes on Twitter. We wanted to be able to share this data, have it multilingual, and just very informally, we launched this and saw this uptake of about 80,000 people. And now we have about 10,000 people who use it every day. And I thought that was a modest success, but the Hospital for Sick Children told us is that they were one of the largest pediatric endocrinology units in North America, and they only see 800 patients once every 3 months for 30 minutes. So having 10,000 people use this free app on a daily basis, they feel is a contribution. So, BANT has some advanced features in that it allows them to do self-monitoring of blood sugars, and there's nothing really any different than what they do now. You can see this Bluetooth-enabled glucometer automatically transfer blood sugars. They receive them in context now, and we're also supporting these devices now that that attach directly to the meter itself. We added a private social media feed where these kids can interact, and what we find is that they don't talk about diabetes very much, but it doesn't matter as long as the app is sticky. They finally are interacting with their peers. We added a gamification element where they get points for every reading they take. They get a ×2 multiplier for that lunch reading that they don't want to take at school, and they get bonus points for taking full 5 readings a day, and they can level up in the scheme and learn about behaviors within the application that will redeem iTunes redemption codes. So it has an extrinsic behavior modification here, because intrinsic stuff doesn't work with this group. We're doing the best we can, and this is the way we're going to try it. And what we saw them start buying these apps, and in the end, we saw a 50% improvement in their self-monitoring in the 3 months that we did this pilot. What we're also doing with BANT is this is the new version of BANT that is going into a full randomized control trial. It has more advanced features, a new social media feed called Banter. It has this trend wizard which identifies high readings, low readings, but doesn't tell them what to do. It just reminds them what are the possibilities? Why did these high readings occur? Why did these low readings occur? And what are you going to do about it? It kind of just prompts them. We are doubling down on the gamification. So you get now points for other positive self-management behaviors. And they're very competitive. What we noticed is they were very competitive in the pilot, so we made it easier for them to be competitive, is we included this leaderboard where they can track how they're doing against all their peers. And again, be able to track their progress along the way using both these incentives. And obviously, we're going to be continuing with this with these advanced meters as they come out onto the market. So that is BANT. And in case you were wondering, we named BANT after this very significant Canadian who happened to have this amazing discovery more than 90 years ago, Frederick Banting, back in Toronto. Now, in older patients, what we tried is hypertension monitoring with the same concept of a Bluetooth-enabled device communicating with a mobile phone. And this time, we used a BlackBerry, another Canadian innovation. No snickering, please. You know, Joe lost his BlackBerry and he wants it back, right? So, the hypertension trial that we had, we did this pilot and saw very encouraging results that we published a number of years ago. You see an improvement in systolic and diastolic blood pressure. And last year we did a full randomized control trial, and this is what we did. We had a basic blood pressure monitor given to the control group, and the intervention group we gave this blood pressure monitor with our app that had reminders, that gave them tips, basically where it was able to trend, alert them to see their doctor as necessary. And this is what we found after a 1-year period. No change in the control group, absolutely no change in blood pressure after a year. The intervention group had a 20% drop in their cardiovascular mortality risk over a 1-year period. The other interesting thing is that no new meds were prescribed. There were no additional visits to the family doctor. This was truly self-care. And we attributed this to the fact that people who were just using the conventional monitor probably forgot to use the monitor because they have no symptoms as a hypertension patient. But the group that was engaged with the application had greater self-awareness by taking the measurements and then subsequently taking their medications on a regular basis. Another application based on the same platform, my colleague Emily Cito, she basically extended this model to a heart failure client, cramming a bunch of other features onto this to be able to manage heart failure patients, blood pressure, single lead ECG. She asked her patients to, before 10 a.m. every morning, weigh yourself, take your blood pressure, take a single lead ECG, and answer a series of yes or no questions on your symptoms. And again, it rolled all this data up and it alerted them in terms of this algorithm that we have to exceptions, and they were able to answer these, and the cardiologist on call was also alerted. But not every single data point was set, only exceptions that were programmed into the algorithm. So the patients like this, and the cardiologists like this, but did it do anything? So Emily went off to do her RCT, N of 100 over 6 months, with this alerting algorithm that she designed with the help of the cardiologist. And the control group was usual care, and this is what she found after 6 months, that the BNP was reduced by 150 points. The left ventricular ejection fraction improved by 7.4%, improvements in self-care, and no change in the control group. You know, another success of just small interventions such as this in order to improve self-care. We also extended this to gestational diabetes and women with type 2 diabetes, and we saw improvements in the type 2 group and greater adherence in the gestational diabetes group. Another application that we did on behalf of the Heart and Stroke Foundation, using the notion that for the general public, we just wanted an assessment of their risk for heart attack and stroke. We have simple 8 questions that you answer. You put in your motivation, why you want to improve your heart health, and then over the course of the 30 days, based on your answers, it gives you little tips, little challenges throughout the day. Things like, you know, plan to have fish for dinner tonight, and fish and chips don't count. Or little things like being able to park your car in a different parking lot and walk the rest of the way. Little challenges that you can either accept or deny or go on to the next challenge. And we tried this over a number of months with the Heart and Stroke Foundation. We had 70,000 downloads over that period, getting all this data to come in. And we actually got about 6,000 people to complete the entire 30-day program, which I think is pretty tough. Like, I designed the application and I didn't make it to 2 weeks. So I considered it a real challenge, and we're going to refine this model in terms of what motivates these people to use this application. And what we've also found is that the people downloading it was mostly women aged 24 to 32. Not exactly the demographic we were looking for. However, they were the first to give up on the application. The older males and older women tended to use it for longer, even though they perhaps didn't download it initially. So again, encouraging results on that. My designer here, these are my notes from my designer, who was noodling on the idea of an asthma app when we were prompted by the Ontario Lung Association. And she came up with the concept of Breathe. We went through a lot of iterations on what would Breathe look like as an asthma application, and then fully render it down. And Breathe is now in a randomized control trial for 400 patients. We really got to prove whether or not this does anything before we release it to the general public. But the point I want to make is that we have a very high bar when we're creating mobile health apps, because you can see 30 Days there and Breathe and Bant, all nestled amongst these other consumer apps. Facebook, Subway Surfer, Angry Birds. Now, which app do you want to tap on right now? Do you want to manage your diabetes or your asthma, or do you want to play a round of Angry Birds? Or do you want to see what your friends are doing on Facebook? So we have a very high bar. And, you know, patients, consumers, they don't give you a discount because you're a healthcare provider. In order to really engage, we have to be as polished as these other applications. So in the end, Breathe is an application that is obviously be able to track your symptoms. It reminds you to take your control medications. It trends these parameters. It actually pulls data from Environment Canada to warn you about triggers that could exacerbate your asthma, a feature that is very popular, and also integrated into your personal health record and your asthma action plan. And it's our first responsive design. It runs on multiple platforms. And again, I really like to see this out to the general public very quickly. Some of the more future applications that we're looking at are these on-body sensors. And this is a group that we're working with in the Netherlands, this IMEC device, which is easily applied on the chest. I saw one of the vendors have a similar device. Very excited to see more of these devices out into the marketplace. And, you know, we started designing software, and the first thing a biomedical engineer does is start plotting the ECG. And one of our engineers said, you know what, what's the point of this? Because patients can't interpret ECG, and he's absolutely right. And yes, it could be used as sort of an online Holter monitor, but we're more interested in these other applications now that ambulatory ECG is possible, that this device can stream ECG for days. You can actually be able to plot stress using something called heart rate variability, using these parameters, plotting the low frequency and high frequency components, a ratio. And now we're looking at all this cognitive behavior therapy, this biofeedback applications, things that were in the lab for decades that we know work. Now we have an ambulatory way of being able to do this, and it's a very exciting time. So this is just a sample of some of the applications we're working on. It's not a panacea. I think we're still in the very early days on what works and what doesn't work. I have to acknowledge my team, a very bright group of engineers who build this technology, but my secret weapon Right off the top is my human factors team. This is a group of young professionals, cognitive psychologists, industrial engineers, human factors engineers, who every day just criticize technology, as they should, constructively, to build better products, safer products for us to use, for patients to use. And you know, we don't talk about this in a speculative manner. We're embedded in Toronto General Hospital, very lucky to be hospital employees working on behalf of manufacturers trying to build better technologies. So it turns back to this notion of hopefully we can get more empathy in the design process. I always turn to Yvonne Maffey, who's the first woman to ever give birth on home hemodialysis to full-term pregnancy. She now has 2 children. She's taken her name off the transplant list. She's doing great. Well done on home hemodialysis. She doesn't want to be on that transplant list. Thank you very much.
Thank you. That was just wonderful. Thank you.
Thank you very much. Dr. Herman, if you're here, would you mind coming up for just a moment? So before you leave, we have the drawing, and I want to ask Dr. Herman if he would do the honors because he has a reputation for complete honesty, and I've been accused in the past of cheating here.
Not from me.
Okay.
Oh, sorry. And the winner,
Kay Aubrey. Is Kay Aubrey here? All right. Well, this is for
on Kay Aubrey's behalf,
yeah,
$100.
$100 Morton gift certificate. So we'll hold that for her.
Another?
And the next one? There are 4. Helen Wari. We'll also be sending emails to their employers, letting them know that they were not here until the...
We don't see anyone.
The next one?
John Herman.
Right.
No.
Chris Sephardi. All right.
You.
Chris works for the center. Come on down, Chris.
You got to pick it up.
Come on up.
Come on up.
One more?
Right, one more. Mini iPad.
Ellie Sofrine. Ellie, I know you're here. Well, she's gone, but she has been here the last 2 days because we've talked quite a bit. She'll be thrilled. Thank you, everyone. We're so grateful that you joined us, and we look forward to seeing you again next year. Have a great weekend.